Today I am going to solve a problem on 1,3 dipolar addition. You can find this problem in CSIR NET exam 2012 June. Here is the problem. When this imine is treated with triethylamine and ethyl propiolate, it gives this pyrrole derivative. What is the intermediate involved in this reaction and what type of reaction it undergoes? Given options are here. The intermediate, is it 1,3 dipolar species or carbenium ion or carbanion? And the reaction, is it cycloaddition or azavity or azacope? Before solving this problem, I would like to discuss about the terms used in this problem. First one, 1,3 dipolar species. This 1,3 dipolar species, it is a reactive intermediate. Generally, the structure of this one will be like this. There will be 3 atoms. In that, on one atom there will be minus charge, and the second there will be plus charge. Afterwards there will be double bond. So these are generally referred as 1,3 dipolar species. The very well known example, it is nothing but ozone, or nitrile oxide. Need not be compulsory that it should be only double bond. It can be triple bond also. Another one can be like this. So this is called azomethane. Azide also can act as (1,3 dipolar species. So these are most common 1,3 dipolar species. The second one, it is carbenium ion. What is this? Is it same as carbene? Are they same? No, they are not same. Carbenium ion, it is nothing but carbocation or carbonium ion. You may be very familiar with this carbocation and carbonium ion, but recently they started to call this as carbenium ion, because this onium, generally it is added when the valence is extra. For example, nitrogen valency is 3. If it becomes 4, then ammonium. Another one, oxygen, the valency is 2. If it becomes 3, oxonium. Similarly, sulfonium, phosphonium. So the valency, it is increased by 1. In the case of carbocation, the valency is 4. If it becomes 5, then you can say that is carbonium ion. But instead of that, it loses this electron and only 3 bonds are there, there is plus charge. So the carbonium ion, it is not a correct nomenclature. So that's why they started to call carbenium ion. Third one, it is carbanium. It is nothing but minus charge on carbon. Now let us go to the cycloaddition. Cycloaddition, it is nothing but reaction in which a ring is formed from acyclic compound. Ethylene gives cyclobutane. So this is a cycloaddition reaction. Another well-known reaction, it is Diels-Alder, gives cyclohexene. Dipolar addition, this is type of cycloaddition. So this is the first step in the ozonolysis. What is aza-Wittig? Wittig reaction, generally it involves the postponium ylide. This adds to aldehyde or ketone to give olefin. So this is Wittig reaction. Is it possible to replace this phosphorus with nitrogen? Then that is called aza-Wittig. So basically this reaction is not that much common, and it is a step in Staudinger reduction. You can get this intermediate in Staudinger reduction, where acid is reduced to amine using triphenylphosphine. Third one, aza-Cope rearrangement. Cope rearrangement, you may know, 1,5-diene upon heating undergoes 3,3 sigma trophic rearrangement to give this compound. If you introduce nitrogen at any position, then that is called aza-Wittig. You can introduce here, here, here. For example, I go like this, so it may be imine, so what I get is enamine or align vinyl amine. So this is called aza-Cope rearrangement. Now let us go to the problem. In this, as I mentioned, there is no minus charge and plus charge. But when you add triethylamine, the triethylamine is basic enough to abstract this proton. Presence of NO2 in the phenyl ring, it pulls the electron towards that. As a result, it becomes active methylene hydrogen. So this can be easily abstracted by triethylamine. So what we get is, further I may get like this. Now you can see that there is minus and plus charge 1-2 position. Afterwards there is a triple bond. So this can act as 1,3 dipole. Now I add ethyl propiolate. It can add in this fashion, or the CO2 ET may be this side. So it attacks here, attacks here. So what I get is N. Afterwards there will be double bond. There will be double bond here. CO2 ET. Under basic condition, this will migrate to give product. If it acts in the other fashion, that is, I get another product like this. So that is called regioselectivity, how it adds to the dipole. Now let's go to the given option. The intermediate formed in this reaction, it is 1,3 dipolar species, not carbonium ion, that is not carbocation. Carbanion, it is formed, you can see here C minus, so that is carbanion. But you not look only at that center. As a whole, it is 1,3 dipolar species. Then the reaction, it is cycloaddition, not Wittig reaction or Aza-Cope rearrangement. So the answer is 1,3 dipolar species and cycloaddition. Thank you for watching. Have a nice day.